So now you might be asking yourself, what is I? It's a great question. I is actually equal to the square root of -1. And we can use I to simplify radicals with even indexes, such as square roots that have negative radicands or arguments in the radicals. An example of that is the square root of -9. Now we know that the square root of regular 9 is 3. So when we think about the square root of -9, you might consider it like the square root of -1 times the square root of 9. So the square root of 9 would simplify to the 3, and the square root of -1 would simplify to I. So this actually works out to be 3I. You always will want to put the coefficient in front of the I the same way you would with variables. Here is another example. The square root of -121. Since we know the square root of 121 is 11, and we have a negative under there, we can simplify this to 11I. Here's another one. What about the square root of -25? I'm going to do another example here in a second that involves the square root of -50. Those two are going to be related. So the square root of -25, you're thinking, that's easy. Square root of -25 is 5I. Perfectly right. The square root of -50, on the other hand, is a little bit more complicated. We will still simplify it kind of the same way that we did the others, although we have something extra going on. We want to consider the square root of -1 times the square root of 50, but since 50 is not a perfect square, let's go ahead and break that down a little further into the square root of -1 times the square root of 25, which is a perfect square, times the square root of 2. Then we can simplify the square root of 25 to be a 5, the square root of -1 to be an I, and the square root of 2 has to be left like it is because it can't be simplified, so this will actually be 5I times the square root of 2. And again, the correct way to write those would be to have the coefficient, then the I, and then the radical. Let's look at one more example like this. How about the square root of -8? Now you want to think to yourself, is there a perfect square that can come out of 8? And of course there is. It's 4. So I want to think of 8 as being 4 times 2, and I want to think about this negative as coming out of the radical to turn into an I. So I'll simplify the square root of 4 to 2. I'll simplify that negative to I, and I'm left with a 2 inside the radical. So the 4 comes out, the I comes out to give me 4I, and then times the square root of 2 that gets left in.